Hello guys, you are watching Oasis Classroom. So today we continued the digital electronics lecture. So we are discussing about the logic gate. So we are discussing about the basic logic gates like AND gate, OR gate, and NOT gate. This is the basic case. We are building this gate. This is the basic, and then we can know that the universal gate. Universal gate. So what is a universal gate? NAND gate and NOR gate is called universal gate. Why? Because we can implement these two gate using these all the gates. And we are having the special purpose gate. Special purpose gate. So special purpose case. So in the naming we are knowing that this is a special gate. So the special purpose case is XOR gate and XNOR gate. So these two gates are called special purpose case. Why special, we are discussing in the later. So XOR gate, so we are discussing about the XOR gate, truth table, logical diagram and all. So for the logic diagram, so if we inputted two gates A and B, so the logic diagram is shown like this. Y is equal to A XOR B means A XOR B, or we can say Y is equal to A B bar or A bar B if A and B are the two input symbol. Okay, so we can implement the truth table of the two gates. So truth table. So for the truth table, if A and B is the input parameter, then Y is equal to A XOR B, or we can say A B bar plus A bar B, we can say. So for the two input symbols, we are having 2 to the power 2 means 4 combination like 0 0, 0 1, 1 0 and 1 1. So for this XOR gate, if we can say that uh, if both the input is same, we can having output as 0. So both inputs same, output having 0, different having 1. So this is called the truth tables of the XOR gate. Or we can say that while odd numbers of 1 is present. So when odd number of ones present, output is high or 1. When odd number of ones not present, then output is low. So for the, if we apply the truth table for three input symbol, so truth table for three input symbols means A, B and C. So I can say Y is equal to A XOR B XOR C. So for three input symbol, we are having 2 to the power 3 means 8 combination. So the combination 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 0 and last 1 1 1. So for this we are having that odd number of ones means from this odd numbers of one present, for this odd number of one present, for this even number of one present, for this odd number of one present, for this even number of one present, for this even number of one present, for this odd number of one present. So for these 5, so we are having output as high, other choice output as low. One. So for this we are having 0 1 1 0 1 0 0 1. For this we are having say that output is 1. So for this odd number of 1 present, so we are having that output as 1. For this also, we are having odd number of 1 present. For this even number of 1 present, so for this output is 0. For this odd number of 1 present, so output is 1. For this odd number of 1 present, so output is 1. So we know that for the XOR gate, if odd number of ones present, output is high. So this is the important concept. So later in the later video, we are discussing about some properties of the XOR gate, and this is the logical diagram of the XOR gate. Thanks for watching. If you need this type of content, please like, share, subscribe to my channel. Bye.